band, rectangular area. Okay. So, let me just give you a quick example there. The area that you're used to is the area between the curve and the x-axis, right? So if I did an area calculation here, I would be calculating something of this nature, right?
Yeah.
Okay? That's what we're used to. Polar changes it. So one way to think about it is rectangular plots points x and y, right? Because you have this area that's formed. How does polar plot points?
On theta.
Yeah, so you have an angle and a radius, correct? That's exactly how the area is calculated. Okay, so if you want to calculate the area inside the circle, okay, polar is actually going to start here, and just like it plots points around the circle, it's going to sweep the area inside the circle. Okay, so think of a fan opening. That's how polar area works. Okay, so it would start here at 0, and it would sweep the area around. Okay, like this. Okay. There are advantages to it because we can calculate area inside of shapes now much more easily than rectangular coordinates, right? Okay. So, polar sweeps the area inside the curve. Okay? Like a fan opening. Think of an opening fan. So a little bit of a different way to think, right? There is a formula for it, though. That's what's really nice.
Does it use our plane?
No, it's very similar to circle area, actually. So if you want to calculate the area of the circle, how would you do it? Yeah, pi squared, right? Okay. Polar formulas are often denoted r equals r theta, right? There's like r equals, this circle would be r equals sine, 4 sine theta. Okay. You got your y-axis circle, because it's sine, right? And this is the diameter. The circles are actually pretty easy to graph in polar coordinates. The formula is 1/2 the function squared. So 1/2 r squared, right? The radius is squared. Very similar. It doesn't have the pi because not every one of these is a circle, but that's your formula for polar area.
Oh, is that B on top?
It's an alpha to beta because we're in kind of a trigonometry mindset now. And we want to distinguish it from rectangular coordinates. Now here's the challenging part about polars. What are those values?
Z.
So if I wanted to calculate the area in red here,
From pi over 2, would that be pi over 2?
Maybe from -2 to 2?
What?
No,
Okay, think in terms of angles.
it'd be from pi to 2
So
pi.
where is 0, 0 gonna be? That's rectangular 0, 0. In polar coordinates, the radius is 0 and the angle is,
Yeah.
all right, so we're probably gonna be 0. Okay, and what output produces 4 as the radius? So what angle, because these are angles, right? What angle makes the output 4? Because that's what this
Pi over 2.
pi over 2. Because sine at pi over 2 is 1, right?
Yeah.
So if we set that's how we know pi over 2, 4 is here. Now notice this circle repeats at pi. See, we're used to our period being 2 pi? Not here. So once you get back to pi, what's sine at pi? 0. You're back at the start again. So if we wanted to area the whole circle, we'd go 0 to pi. Half of it's 0 to pi over 2. So our formula will be 0 to pi over 2. And we'll have sine, sorry, do it again. 4 sine remember to square both items. What's 4 squared?
16.
So it's 16 over 2. 0 to pi over 2 sine squared. Okay. Can you do that by hand?
Oh, you did very well. Okay.
Okay, this is going to be a calculator problem most likely,
Is it?
unless you know your trig identities.
Well, sine of pi over 2 is 1, isn't it?
I'm sorry, it's square, sine squared.
Which is
You can't
like
integrate
squaring the
that.
whole thing. Oh, integral.
Yep. So if you want to do this by hand, you have to use this identity. Okay, which of course they don't ask you to memorize, so we're not going to ask you to do that on the AP exam. Most of the time, they're going to just say, write the equation. Okay. Or give you a calculator. If you're going to be in a calculator, guess what? You have to be in polar mode. Because polar area sweeps differently than rectangular, right?
Yeah.
Okay, so be careful. If you are working with polar coordinates, you want to be in polar mode in the calculator. Okay. You want me to run through that?
Yes, please.
So go to your mode. So we have function, parametric, and polar. And you can do sequences here too. I never showed you that, but you can plot sequences as dots. It doesn't do series plots, but it does sequence plots. So there's your polar mode, and when you go to y equals, changes it to r equals.
And your x becomes theta?
So we had, what, 4 sine theta? And it changes it all there for is. Right? And then when you do your math 9, look at that, 1/2, math 9, 0. R1 theta.
Don't you have to do R1 squared?
Oops. Gah. See, you gotta pay attention with these because you get into go mode and it just happens. There we go. There we go. And then if you wanted to, pi r squared divided by 2 will give you the same answer. It's a circle, right?
Yeah.
There you go.
So this kind of stuff, this stuff matters when you get like a more specific angle and use pi over 2.
I'll show you one right now, actually. Okay, let's do sketch r equals sine 3 theta and calculate the area of one petal. On the AP exam, they might say the area in quadrant 1. Some of that just depends.
So from 0 to pi over 2.
No,
No,
this is where you have to be careful. Okay, this is
Oh.
not 3 sine theta. This is not a circle. Okay, this shape looks like this. And again, you can graph that in your calculator. Okay, sine 4 theta, how many petals would it have?
1.
Sine 5 theta. I get it, okay. Here's the question. You want to find the area of one petal. Remember, it's this, we're sweeping the area now. How do we get from here to here?
30 to 45 degrees?
You're guessing.
Yeah.
Is that 1/2?
Yeah.
Okay.
Find where it intersects the y-axis.
A logical place to start is at 0. Okay, so where are we at 0?
0.
Sine at 0 is 0, right? Okay, so we have 0, 0. What about pi over 6? It's sine at 3 pi over 6.
Let's find out.
Half.
3 pi over 6
1.
is pi over 2. That's 1. Okay, now let's go to pi over 3. We're just making our way around the unit circle in an easy manner. plug power 3 in. And you assign a pi, which is
0.
0. We're back to the original starting location.
So we go from pi.
0, 0. Here's pi over 6, and pi over 3 actually comes back to here. So what are our boundaries going to be?
0 to pi. So it's the distance to go through the full rotation.
Yeah, one pedal is 0 to power 3. Okay, you want to know a really slick way to figure that out?
Yeah.
Turn your calculator to rectangular mode. Or function mode. Y equals sine 3x.
Where did it intersect the x-axis?
Yeah.
Huh.
And I'm going to adjust my window a touch. So we go from 0 to 5. There we go. How many pedals are there?
3.
3. 1, 2, 3.
Oh.
That's how those, yeah. Right, so there's pedal 1, that's what we've read. This is pedal 2, and then pedal 3 is here, then it would repeat. Okay. So the question would be, what is this spot right here? All you have to do is
Pi
a
over 3.
calculate an intercept, right?
Would be 0.
No, it's going to be pi over 3 because that's the
It
math.
gives you the x value. Oh gosh, let me get clear. That's dumb. Calculate a 0, sorry. We want the 0. There's pi over 3. 3.14 divided by 3. Okay, so that will work too, if you have a calculator. It's pretty slick. Okay. Go ahead and calculate that up. There is a trig identity for that as well.
Do you need it since it's sine 3 theta instead of 3 sine theta?
Yeah, you have to use a trig identity on this if you're going to solve it. It's cosine 6. Yeah. If you're going to do it by hand, but calculator wise, what you get. you get? Oh, that is slow.
0.261.
What was it?
261.
Okay. I think 5 or 12 is what you're gonna get. Is what the book says. Did you do that with the half and the square?
Yeah.
Yeah, pi over 12 is equal to that.
Okay. All right, so that's polar area. Let's talk about doing the area between two curves now. Okay. Let's say, calculate the area. Area outside R equals 1. But inside R equals 2%.
What's the circle of the diameter of 2 and a circle with a radius of 1? Are those just the same circles?
No. They're
Because of the
different
origin
locations.
of close.
What's the center of this?
0.
0, 0. But the center of this is... Wow, that does not look good. The center of this is 1, 0. So here's what we're looking at.
Sure. Cool.
That's R equals 1. Cosine theta. So we are looking at the area outside R1, R equals 1, inside cosine theta. Right?
So then it would be outside minus inside?
Yeah, so same deal as it's the same thinking. Call this one number 1 and 2, I guess. So, yeah. So basically it's outside minus inside. Kind of like volumes of revolution, out minus inner. Right minus left, top minus bottom. It all matches the same. Okay, question being, what are those two locations?
Do we ever have to do
Thinking in a
that?
sweeping mindset, if you have a sweep from here, and it's gonna go out, right? You have the outside sweep from there to there, and then the inside sweep from there to there. Okay, so what are these intersection points? How would you calculate that?
Did you set the arms equal to each other?
So R cosine half equals theta?
So R is 1, R is 2 cosine theta, set them equal to each other. Solve, so divide by 2, where's cosine of half?
Five or six.
3 over 2.
3 times? No, power 3.
Out of 3. And
2 pi over 3.
no,
No?
it's negative half there.
Oh.
So,
4 pi
cosine
over
is
3.
negative in these quadrants, so where's this?
The.
Pi over 3,
40,
3 pi over 3, 6 pi
4
over
pi
3,
over
4
3.
pi over 3, 5 pi over 3. Okay. Now, to make this work, do you want to go from here to here?
Yep.
No, we don't. That's what this order implies.
Go,
there.
so we did it.
Five
Now,
pi
we
over
agree here, correct?
Yeah.
But, think this through, that doesn't, it's not a very logical way to do it, right? So what is another way to write this? If I want to go backwards and start here. Negative what?
Negative 5 over 3.
Negative pi over 3. If I
Oh.
take negative pi over 3, that's the same spot. So now it's going to go from negative to positive. Okay, so just be careful there. You should do that right. Yeah, I told you that the key here is those points of limits of integration. Okay, figuring those out. And then we can do outside minus inside. 2 cosine theta squared minus 1 squared. And then calculate that up. Should get.
I got 1.193.
1.913.
1.913. I can read it.
Scared me there for a second.
No. That's not me.
One of us is having issues.
Me.
No, it's just like close.
11.4A, 3, 1 through 3, examples 1, 3, 7, 9. Quart?
Part,
Part.
number 9, part 1.
Oh,
That's number 9. Part 1. Just markers. I guess I could change the size of the pen, huh? Somehow. I'm sure there's a way. All right, let's. We can, I can give you 2 days on that if you want. We can start at WA tomorrow morning. If you want. You're gonna have to do that.
Yeah.
Is this for A and B or?
No, this is just half of the section. So take 2 days